Okay, in Linux, the system boots up and initializes in a certain process. And as we've learned with basic computer hardware, the boot process usually is done when you first turn the computer on. It loads BIOS. From BIOS, it loads post. And then from there, it looks to the master boot record, essentially the first sector of the hard drive. And there it's going to find information in order to load the operating system, specifically to load the kernel and where to find that kernel. So in Linux, we use one of two bootloader programs called Grub or Lilo, which is the Linux loader. And we're going to take a look at our current installation. We're running Fedora, so we're going to see the Grub is what's going to be used. Once the Linux kernel loads, then the init process takes over, the initialization process, which is init. And that process is then going to initialize or start all the other daemons that are going to be running in the background, which are programs that are running in the background. So we're going to take a look at all of those right now. I'm going to take a look at the files that are associated with them. You guys can follow along if you want to. So on our system, if we do a df-h, we see that our main file system is root, and then we have a temporary file system, and then /dev/sda1, which is right here, is our boot partition. So this boot partition is about 485 megabytes in size. And that's where our bootloader is located. Again, I did that command with df-h in order to get this output. So let's take a look at the boot partition. So if we change directory into boot and change directory into grub, we can see this is where all the grub configuration information is located. Let's take a look at the grub.conf file. So cat grub.conf, and we can see some information here. Starting right here, we go down to the full configuration file. Looking at some of these, anything with a pound symbol in front of it is just a comment. And starting out, default 0 is going to identify that the Linux kernel is on the first hard drive, which is signified by 0. And then timeout equals 0 is how long it's going to wait before it actually starts loading. And here we have timeout of 0 seconds. We could change that to 5 or 10 or 3, however many seconds we want it to wait. We might want to change the how long it is for this to be displayed, so we can decide whether or not we're going to load another operating system if we're dual booting. The splash image is showing that on the first hard disk, in the first partition, in the grub folder, there's a splash xmpgz file, and that has the actual image that's going to be displayed at boot up process. So it's that nice wavy image that we see when we first boot into our system. And then we have hidden menu, meaning don't show any kind of menus after the kernel loads. The title. This we could change if we wanted to. It says Fedora and then the title. We could change that if we wanted to. And then root is going to be located on this first partition of the first drive. And then the actual kernel itself is identified here with the kernel note. So it's VM Linux or Linux dash and then the kernel number 2.6.33-385 PAE. And it is initially loaded in read-only mode, so we don't affect any of the actual kernel itself. And then we load that kernel into a RAM disk. And that's what all these other settings are here as well. and this showing our volumes that we're going to be our volume group, where it's going to be loaded, and so forth. So that is a basic Grub file. You will probably only go in here and edit the Grub file if you're going to be modifying or dual booting, which is not too common with Linux file systems, with Linux systems in the back end of infrastructure. So if you have a Linux server running, you're not going to be dual booting it because it's going to be wanting to be running all the time. The only time you dual boot is if it's your own personal system you can be playing around with. So that's not too common to dual boot and mess around with it. If you do have another kernel, let's say that you had to compile another kernel, this is where you could identify or change the kernel file that you would load. So let's say you got the new 2.8 kernel. Then you would have to come in here and change this to match the actual file for the new kernel that you're going to load. And if we take a look in here, there is my kernel. So the present working directory that I'm in is just in the /boot directory, which is here that I've highlighted is the actual kernel. So there's VM Linux 2.63338. So that's the actual kernel that we load. Now, Lilo, or Linux Loader, was traditionally used, but it's essentially no longer supported by a lot of different distributions. It is used in a few, but most of them, when it comes to Red Hat and CentOS, it's not being used. So if you want to, you can take a look in your book for further information, but the configuration file for Linux Loader is in the etc folder. So if we change directory /etc, and we can cat the lilo.conf file if we had it, and we don't have it because we don't have Linux Loader running on our Fedora system. It's just Grub. Okay, moving on, we take a look at the initialization. So after Grub loads, it loads the kernel, and then from the kernel it loads the init process. Well, the init process we can see in the init tab file, and that is in the etc folder, which is currently where I'm at. If I do a pwd, I can see I'm in the etc folder. So if I cat that file, init tab, so init tab, hit enter, it's going to show me that obviously the pound symbols show that these are all comments and giving me a default run levels. So we have 6 different run levels for Linux. And the first run level is halt. Essentially, do not set the init default to this, because when the kernel loads, then all of a sudden your system's just going to halt. It's going to stop, which essentially means just turn off. So it'd be a cool trick to play on somebody, but kind of rule. Yeah, and then 6, it would boot, and then reboot, and yeah, so it wouldn't be fun. So let's go over some of these different run levels that init initializes and starts up. So in single user mode, this is the system that has only enough daemons or processes to run for one user to log in and perform basic system maintenance that you would need to run. The next level, level 2, is a multi-user mode, just like single user mode, but it has more daemons that it can run, so you can have multiple users log in and use some of the network services that are available, where you don't have any network services in single user mode. So that's key. If you're just going to log into the system and run some checks or repair some disks or mount disks and do different basic maintenance tasks, then you want single user mode, but you don't have any internet or network access. If you wanted network access, you'd have to use multi-user mode. So, but it says this is without NFS, meaning that you're not going to have any network file systems. So you're in multi-user mode, but it's only so multiple people can connect to it, but you still don't have all the daemons, and you don't have any networking access as well. The next one is the most popular for a text-based installs, and that's run level 3. It's a full multi-user mode with all the daemons that are supposed to be supported, and it is the most popular one. As you can see down here, the init level is set to 3 on my system. So this line does not have a pound symbol in front of it, therefore it's identifying that this is the default init level 3. If I did have a GUI installed, a graphical user interface, like GNOME or KDE, then I would set it to 5, and it would boot into the graphical user interface. So that's how you can change it. Now this run level 6 is where we can actually use it to change our run levels, so it will essentially reboot our system. So to give those a try, we can change our run level. First, let's take a look at what our run level is. We just type the command run level, and it tells you that we are in run level 3. And if you want to change to run level 1, we just type the command init space 1. And we will now shut down the different services that are not needed, and we are going to go into run level 1. So now if I type run level, I now see that I'm in the run level 1. For a single user. Yep. Because the N identified the network, or the non-existent. So to change back to run level 5, we can just type init, oh, not 5, we want to do run level 3, because we don't have a GUI, so init 3. And then it will start loading the different modules or daemons that are needed to be in that run level. Oh, and it's prompting me to log in. Did you see that difference? So log in as root. I gotta type in the right password. And if I do init1, notice that it dumps me right at the command prompt. So this has become somewhat of a disaster recovery of a system. If you have forgotten the passwords, you can load into run level 1 single user mode and then change the etc password file, which is where all the passwords are, or the user accounts are stored with passwords. Remove the password for root and then get in there. So there is one extra step that you have to do, and that's where you have to modify the kernel, which is in the grub.config. You have to modify the boot partition in order to make those changes so you can boot into run level or single user mode. That is why you want a bootloader password. So when it does load grub, it prompts us for a password, so you can't break in there and actually modify the kernel loading into run level 1. So that prevents somebody from being able to get in, which is good because it's secure, but bad because if you do forget the root password, then you're not going to be able to recover, and you're going to have to probably do a reinstall. So good and bad with additional security. So again, we're in single user mode, so now when I change to run level 3, init 3, notice it takes me to a prompt to log in. So I have to log back in when I'm in run level 3 or run level 5. Okay, so I'm back in, change directory /etc. So I'm in the etc folder, and if we wanted to change the run level, all we have to do is edit the init tab file, and we'll be able to see our system boot into that different run level. Okay, so all of the different daemons that load based on the run level that we're going to be at, and those daemons that you saw the processes load on the right hand side, it said okay, okay, okay. Those are all identified in startup scripts, and those startup scripts are in the rc folders. So we need to change directory into the rc.d folder, and inside there we'll see all the other ones. So we're going to change directory space, and just to make sure we're in the right folder, we're going to do the full path. So /etc/rc.d. Hit enter. And just to make sure, pwd, we should be in the etc/rc.d folder. If we do an ls directory listing there, we can see the init.d, rc0, rc2, rc4. Here's the rc3, which is the run level 3 directory, which has all the scripts for the run level 3. So if I were to take a look at it, ls rc3.d, I can see that we have all of these startup scripts. The K means kill. Means kill the SmartD service. Kill the SSD service. Kill, what other ones do we have? Kill the network service. And the S means start. Start the LVM2 monitor, the logical volume monitor. Start the IP6 tables, and then the normal IP version 4 tables. And the number after the letter signifies what order to load these in. So obviously we see it goes from 2 and jumps right up to 8. So it doesn't have to be one right after the other. There doesn't have to exist a 3 and a 4 and a 5 and a 6. Those are spaces open for you to throw in your own if you needed to modify, or they're just by default. IP tables is always started as start number 8 in the list, just because by the time number 8 loads, we will have our network loaded as well. So let's take a look at run level 1. ls rc1.d. So we do a directory listing of run level 1 and all the daemons that start there. So as you can see, there's only a few of them.
Most are kills.
Yep, most of them are kills to make sure that we don't have any running. So again, this is all a single user. All right. So if we move on and take a look at the actual script or the command that's run, we want to do a long directory listing. So if we do an ls rc3.d, but we use the ls -l command, it's going to give me a long directory listing. And as you can see, all of these daemons are actually a soft link to the actual executable file. So NFS lock is started in number 24 in order, but it's actually executing the init.d.nfs lock file in the init.d file, or I'm sorry, the init.d folder. And if we remember from doing a previous ls, we can see that there is an init.d folder or directory listed right in the rc.d folder. So if we change directory into the init.d folder and do a directory listing, ls, we can see all of the actual daemons that exist on this computer. Whether they're loaded or not is determined based on what run level, which is determined based on what start script file is identified inside of the rc3.d or the rc1.d folder. So those are all my different services. One of them that we're fairly familiar with is the SSH service. And you can see on the far right side of my screen the SSHD daemon. I highlight it right there. So that daemon we can start and stop by using a command, by using that command right there in that same directory. So we can do make sure that we are in the present working directory in the init.d folder. So we can do a /sshd space reload, and it will reload the SSH daemon. Or we can do the same command, /sshd space stop, and it will stop the SSH daemon. So if we want to start the SSH daemon, we type /sshd start, and then it will start up the SSH daemon.
Is there a way to tell what is actually started already without doing?
Yes, you can use the service command. And here are the options for the service command. So you can do the service command status all. So we would type service space dash dash status dash all. And it will tell you all the different services and whether they are running or not. So the SSHD service, if I page up, I can't find it by just looking through it here, but we can grep this command. So we can use the same command and just pipe it to grep and look at SSHD. And it's not in there. Well, we can use service and yeah, status all should have showed us service SSHD space dash dash. Actually, we just do that and do a status. And it shows, oh, it's OpenSSHD. That's why it didn't show up when I did the command, because it's actually called the actual OpenSSH, which is the name of the open source project for SSH. That's why I didn't see it. So let's do that again, and we'll show that off. So I'm going to type service space dash dash status dash all. And that shows all the different services. So you can see them all go through here. So if I clear the screen and do that same command again, I'm just hitting the up arrow, by the way, to repeat my commands. Space, pipe that to grep and look for SSH. And it shows me that the OpenSSH daemon, so SSHD, which has a process ID of 2953, is currently running. So if I execute that command to stop the SSH service, /sshd space stop, and then I repeat the command to see what the status is of SSH, and it says the SSH daemon has stopped. So how to restart that service up again? Yep, /sshd start. And again, we're doing this from the etc rc.d directory in the init.d subdirectory. But using the service command, we can use service SSHD is the name of the service space restart, and it will shut the service down and start it back up. That service command is able to interpret all the different services that are running inside of the init.d folder. Now, to determine whether or not a service is running, we would have to take a look inside of each one of the run levels folders, correct? The rc.d folder or the rc.1 folder. But what we can do is we can take a look at the actual service itself and see what it's configured to start in, what run level it is configured to start in. And we do that with the check config command. So let's do the check chk config space dash dash list space sshd. So we can see the sshd is set to run in run level 2 and run level 3, 4, and 5. So sshd does not run in the run level 1, and obviously not in the 0 or 6, because that's where it shuts the computer off or turns the computer into a reboot. Now, if I wanted to turn the SSH run level off in run level 5, we would do the check config file or command dash level. Actually, I think we need 2 dashes in there. So dash dash level space 5 space sshd space off. So we're running the check config command, identifying level 5. I want the service sshd off. And now if I run this command to list the run levels that sshd is running in, I can see now that run level 5, it is off, where before it was on. So the command to turn run level or sshd on run level 5 on would be hit the up arrow a couple times. Yep, just change the off to on. Very easy. And now we can check it. Hitting the up arrow a couple times, the previous command I did, and now run level 5 SSHD is set to on. And that's how you can start and stop different services, like the HTTP daemon, the web service, the MySQL. There's a lot of different services that we'll be working with. Bind, which is actually DNS, and DHCP. All those different services, you can ensure that on run level 3, which is the text-based interface, we have those services that we want turned on. And we can do that with the check config command. Are there any questions on the initialization process? No? The rc.sysinit, if I take a look at that, it is a file, and the rc.local is a file as well. So if we take a look at those, cat rc.local, this script will be executed after all the other initialization scripts are run. So what this does is if you want to modify or run a script right after the system is booted, before anybody logs in, this is where you would run it. Notice the touch command. If you remember what the touch command does, if I do touch Aaron and do a directory listing, what touch Aaron does is just creates a file called Aaron and then identifies ls-l. You can see the file is Aaron. It creates a file, 0 bytes, but it gives it today's date and time. It updates the date and time on it. So if I do a touch Aaron again, do a long directory listing, you can see that the time has changed from 2137 to 2138 because it just updates the time. So I'm going to remove Aaron and do a directory listing, and we're going to cat the rc.local again. And what this is doing is just creating it's touching a file to update the time and date that file is run every time the system is boot. So again, the folder that I'm in is in the rc.d, present working directory. So you can change directory to the /etc/rc.d folder, and you can see the rc.local file. This is again where you can specialize or put any kind of personalized scripts at the time the system is booted before anybody logs on to the system. Let's take a look at the rc.sysinit. Cat the rc.sysinit file. And in here is the system scripts, and let's just use the pipe more. And we can see that at the beginning, it identifies the host name of the system. And where does it get the host name from? It gets it from the bin hostname file. And these are all run at the time the system is started up. So here it's identifying if there is a network file, then run the sysconfig network file and set the host name, which is right here. So otherwise, then set the host name to localhost. So all of these things are running at the time the system initialized. But again, you don't really want to modify the rc.sysinit file unless you have to. You want to modify the rc.local file, which is where you can set local specific system changes and settings. So that's the basic Linux initialization. The rest of the chapter kind of gets into the X Windows system, but we're not going to mess with that because we're focusing on server-based Linux commands. I'm going to hit Q to quit out of this, and that was it. Next, we'll take a look at managing the different Linux processes.